So here we have written 0, t by 4, t by 2, 3t by 4 and t for one oscillation. So displacement x is equal to, as the graph starts from positive extreme, so it is plus a, the amplitude is maximum, so it is, we can write this a, it is a plus a, then it is pi, so it is coming to mean, it is again comes to mean position, so it is pi. So it is x is displacement is 0, it is going to negative extreme, so here it is 3 pi by 2, so it is minus a, that is, as it is going to negative extreme, again it is going to mean 2 pi, so for 2 pi it is 0 again, displacement is 0, and from here mean position again it is going to positive extreme, this position, so we can write here a again. So this is about the displacement versus time graph. Then next we'll see the velocity time graph, that is the velocity and time. We have the equation x is equal to a sine of omega t plus y, that is the a cos of omega t for the displacement. For velocity we have velocity is equal to dx by dt, displacement with respect to time. So here differentiating this equation we can write d by dt a cos of omega t, that is minus of a cos derivative minus sine, so we can write here minus a omega sine omega t. Here the velocity graph, it is starting from the mean position, so we can write negative mean, so here we can write the extreme, this positive extreme, it is negative extreme, and this is the mean position. So particle is at the negative extreme position, so sorry, it is at the mean position, it is at the mean position, so this is the initial position of the particle. It is not moving to the positive extreme, it is moving to the negative extreme position, so this is the first, this first, then it again goes to the here mean position, this mean position second, then from mean position again it goes to the positive extreme, from mean position it goes to the positive extreme, this position, and from positive extreme it goes to the mean again, from here it again goes to the mean. So the motion is from mean to negative extreme to mean, mean to positive extreme, and positive extreme to again mean. So the graph will be like this. So if we take the values as 0, again for the one oscillation the t is divided again like same, 0, t by 4, t by 2, 3t by 4. So here again these values of theta, as this particle it is at the mean position, so we can write here that v is equal to 0. Then from here it is moving towards the negative extreme, so this negative extreme, so this value negative extreme it is minus of a omega, we can say. Again from negative extreme it is going mean, so this will be again 0, that is for t by 2, or we can say it is 3 t pi by 2, it is 0 again. Then from here it is again goes to the positive extreme, so this position it is plus a omega, it is plus a omega, and from here it is again going to the mean position, this position is so we can write here 0 again, mean, for the mean we take it's 0, so displacement 0 minus a omega, 0 plus a omega, and again 0, that is the mean position. So this is the velocity time graph. So next we will see the acceleration time graph, that acceleration versus time. As we know the equation for displacement and the velocity, it is v is equal to minus a omega sine of omega t. So for acceleration we can write dv by dt, velocity is v is equal to minus a omega sine omega t. So we can write here dv by dt, so it is d minus a omega sine omega t by dt. That is, we can write this, differentiate in this equation, it is minus a omega square, sine derivative is cos omega t. This omega is constant, so it becomes omega square. So here the acceleration and time graph. Here the particle starts from this negative extreme position. This is the negative extreme position, and here we'll see this is mean again, this is negative extreme, and again here positive extreme. So where is the position of particle? This particle is initially here. From here it is going to mean position first, this mean position. From mean position it is going to the positive extreme, this is second position, this is going to positive extreme. From positive extreme again it comes back to the mean position, this again it comes to the mean position, and from mean position again it is going to negative extreme. That is, this is the negative extreme, and one oscillation completed. So we have the graph like this. We again have t, time period, theta, and the a. So it is t by 4, it is 0, so it is pi by 2. Let it, and here t by 4, it is pi, it is 3 pi by 2. It is, we can say it is pi by 2, 3 pi by 2, it is 2 pi, and 5 pi by 4. In terms of phase we can write. So here this is the initial position, here pi by 2 initial position. So we can write here it is minus of a omega square, this term, minus of a, sorry, it should be capital, minus of a omega square. From here for t by 4 or pi, this is the position, so it is 0, that is the mean position. Then next is 3 pi by 2 or t by 2. So t by 2, 3 pi by 2, again it is this position, that is the positive extreme, so it is plus a omega square. From here this 3t by 4 or 2 pi, so it is again mean position, it is 0, and from here it is going to t, that is one complete oscillation, 5 pi by 4, so it is negative extreme, so we can write here minus a omega square again. So this is about the acceleration time graph.